Okay, so we want to introduce the empirical rule now, which is a shortcut way to figure out the probability of being within whole number values of standard deviations above or below the mean, and it also helps us figure out the probability of being within whole number standard deviations above the mean. So here's what the empirical rule tells us. For distribution, for any data sets that are approximately normal, about 68% of the values will lie within one standard deviation below and one standard deviation above the mean. So the probability that we have a z value between -1 and 1 is approximately equal to 0.68. Okay? The next part of the rule, part 2, tells us that 95% of the populations will be, of the observations will be within 2 standard deviations of the mean. So the probability that we have a z-score between -2 and 2 for any distribution that's approximately normal is going to be about 95%. And then finally, we expect 99.7% of the observations for any distribution, any data set that's approximately normal, to be within 3 standard deviations of the mean. So a probability that we have a z value between -3 and 3 is going to be approximately equal to 0.9970. We're going to be able to calculate our probabilities more accurately than this after the next module's lesson, but for now this gives us a great starting point and lets us also think about, when we do our other calculations, whether our answers are reasonable or not. So again, what we're seeing is that 68% of the observations lie within 1 standard deviation of the mean. We have within 2 standard deviations of the mean, we're going to have 95% of our observations. That didn't show up quite like I wanted it to. So 95% of our observations are going to be within 2 standard deviations of the mean. And then within 3 standard deviations, again, we're going to see almost all of our observations, 99.7% between -3 standard deviations and +3 standard deviations. So let's look at applying the empirical rule to some application questions. So we're told that the high temperature in San Francisco in January is 55 degrees Fahrenheit, and the standard deviation is 3 degrees Fahrenheit. And the distribution of these temperatures is symmetric and bell-shaped, so approximately normal. So we want to figure out the range of temperatures that would include about 68% of January days. So how do we do this? Let's get started. So what we have to do is think about that 68%. Which of our rule does that apply to? So that's plus or minus 1 standard deviation for 68 degrees, so, or 68%. So that tells us that our lower limit for the range that we'd expect our values to be between is going to be our mean minus 1 standard deviation. So it's our mean minus 1 standard deviation. So our lower limit on the range is going to be 52 degrees Fahrenheit. Our upper limit is going to be our mean plus 1 standard deviation. So it's going to be 55 plus 3, which gives us an upper limit of 58. And so what does that mean? Therefore, 68% of the days are expected to be between 52 degrees Fahrenheit and 58 degrees Fahrenheit. Conversely, it also tells us that 32% of the days are expected to be outside of the range. Okay, so let's work on the next two questions. So the next two questions are actually, if we look at them together, very similar. So question B says the range of temperatures that would include 95% of the January days. So the 95% corresponds with our empirical rule that says that 95% of the values will be plus or minus 2 standard deviations. So for part B, our lower limit is going to be found by taking our mean and subtracting 2 standard deviations from that value. So we're going to have 55 minus 6. So we're going to have a lower value for that range of 49 degrees Fahrenheit. Our upper limit is going to be found by the mean plus 2 standard deviations. So we're going to have an upper value of 61 degrees Fahrenheit. Okay, so therefore 95% of the days are expected to be between 49 degrees Fahrenheit and 61 degrees Fahrenheit. Again, our third example here, when we change the probability or the number of the percent of the data set of the data values we want to include, then we have to change the number of standard deviations that we move out from the mean. So we want to find the range of temperature that would include 99.7% of all January days. We'd have to go plus or minus 3 standard deviations, right? So our calculation looks pretty similar, but the lower limit is going to be the mean minus 3 standard deviations, which would give us a lower limit of 46 degrees Fahrenheit. And we'd have an upper limit of 55 plus 3 standard deviations, which works out to 64 degrees Fahrenheit. Okay, so therefore 99.7% of the days are expected to be between 46 degrees Fahrenheit and 64 degrees Fahrenheit. Okay, rather than asking those forward-facing questions, we can also solve some backwards-facing questions. So we want to figure out, given a range of values, what percent of the days are expected to be between 52 degrees Fahrenheit and 58 degrees Fahrenheit. To figure this out, we might want to figure out what the Z values are associated with those particular values. So for a value of 52, we know that with a mean of 55 and a standard deviation of 3, that corresponds to a Z value of -1. The second value that we're asked, the upper limit we're asked to consider, is 58. A value of 58 has a Z value of +1. So we want to know what percent of days are within 1 standard deviation above and below the mean. And the answer to that, of course, is our 68 rule. So 68%, tying it back to the empirical rule. Okay, pretty straightforward. We can make the questions a little bit more interesting by adding some asymmetry to the question. So let's look at a little bit more complicated question in the next example. So here we're asked what percent of the days are expected to be between 49 degrees Fahrenheit and 64 degrees Fahrenheit. If we start off with the same method that we did last time, we can see that 49 is 2 standard deviations below the mean. It has a Z score of -2. And 64 has a z-score of +3. So what's going on here is we're given a question that doesn't fit exactly into our empirical rule. We're trying to figure out what's the probability that we're either 2 standard deviations below our mean or 3 standard deviations above. If it was 2 standard deviations above or below, that would be fairly straightforward. We know that there's 95% of the observations are plus or minus 2 standard deviations. And so the tricky part in this example is figuring out how much area is between 2 and 3 standard deviations above. Okay. We can figure this out though. We know that plus or minus 3 standard deviations is 99.7% of the data. So the green shaded area that I have in the graph must be the difference between 99.7% and 95%. So that comes out to 4.7%. Because we only want to figure out half of that shaded region, we can take the 4.7% and divide by 2, and it comes out to 2.35%. So our final answer, we're going to have the 95%, that's plus or minus 2 standard deviations, add on our 2.35%, and get our final answer of 97.35%. So therefore, we'd expect 97.35% of the days to be between 49 degrees Fahrenheit and 64 degrees Fahrenheit. Okay. So next part, it's time for you to practice. So we've got 2 sets of practice questions here. Okay. The first 3 questions, pause it, try them out, check your answers. Okay. For part A, it's between 55 and 75 pounds, plus or minus 1 standard deviation. For B, it's 35 to 95 pounds, plus or minus 3 standard deviations. And then for part C, we have to realize that 45 to 85 pounds is plus or minus 2 standard deviations, which corresponds to 95% of the observations. 95% of 200 is 190 children. Have any questions, contact your instructor, attend office hours, or sign up for tutoring. Okay. Next practice question to work on before you go and do your homework. Okay. So the distribution of weights for a sample of 140 cargo containers is normally distributed. The standard deviation is 120. Based on the empirical rule, what percent of the values will lie between the following ranges? Pause the videos, think it through, and then check your answers. The answer for these questions are 68%. This is our basic plus or minus 1 standard deviation question. For part B, it's 34%. It's half the value, half the area of part A. And for C, it's going to be 476 containers. It's 34% of the total number of containers. 34% of 1,400 is 476. Great work. Don't forget to do your homework and ask any questions if you have them. Take care. Talk soon. Bye for now.